In graph 22.4, we illustrated a separating equilibrium under asymmetric information, an equilibrium where the types of insurance policies that are offered cause the high-risk types to choose a different policy from the policy chosen by low-risk types. A second type of equilibrium is called a pooling equilibrium, an equilibrium in which both types end up choosing the same insurance policy from those that are offered. As we will see here, whether a pooling equilibrium exists will depend in part on what fraction of the population is of high-risk type and what fraction is of low-risk type. We begin with the set of actuarially fair insurance contracts that are aimed at high-risk types. The actuarially fair set of insurance contracts aimed at low-risk types is shallower because delta is less than theta. If there is a pooling equilibrium in a competitive insurance industry, it must be that the policy offered in this equilibrium results in zero profit. In any pooling equilibrium, both high-risk and low-risk individuals will purchase the same policy. Thus, in order for that policy to result in zero profits, it must lie somewhere between the zero profit or actuarially fair insurance policy line for high-risk types and that for low-risk types. Where exactly it lies depends on what fraction of the population is high-risk and what fraction is low-risk. If the fraction that's high-risk is half and the fraction that's low-risk is half, then the set of contracts that would result in zero profit if both high and low-risk individuals bought them would lie halfway in between those two lines. In panel B, we'll now investigate whether any of the insurance contracts that lies on this zero profit pooling line can in fact be in equilibrium when gamma is equal to 1/2, where gamma is the fraction of the population that's low risk. If there is such a pooling contract, it must give more utility to high-risk types than they could get by fully insuring along the actuarially fair insurance line aimed at high-risk types. If it wasn't, an insurance company could simply open and offer the actuarially fair insurance contracts aimed at high-risk types and attract all the high-risk types away from the pooling contract. When offered all the actuarially fair insurance contracts aimed at high-risk types, we've previously found that high-risk types will fully insure at the insurance policy A. If there is a pooling equilibrium, it must therefore offer an insurance contract that lies on the zero profit pooling line and below the magenta indifference curve that goes through point A. In graph 22.4, we also found the highest possible indifference curve that an individual of low-risk type could attain in a separating equilibrium. That blue indifference level is attained by purchasing the insurance policy B that's offered in a separating equilibrium. And that insurance policy B is chosen from the highlighted green segment of the actuarially fair insurance policy line aimed at low-risk types. It is that segment of the actuarially fair insurance policies aimed at low-risk types that can be offered in a separating equilibrium. And that segment can always be offered by an insurance company, even when there is a pooling equilibrium. Thus, it must be that if there is a pooling equilibrium, the low-risk individuals must attain greater utility at that equilibrium than they would in the separating equilibrium. Otherwise, an insurance company could simply spring up, offer the insurance policy B, and get low-risk individuals to separate from the pooling contract. Under the conditions depicted here, a pooling equilibrium is therefore not possible. Individuals of low-risk type can attain the blue utility level by simply purchasing policy B, which can always be offered. The blue indifference curve lies to the southeast of all the zero-profit pooling contracts. Since low-risk types always do better under the policy B than they do under any possible zero-profit pooling policy, they will not enter a pooling contract within a competitive insurance equilibrium. The reason for the non-existence of a pooling equilibrium here is that there are too many high-risk types. If the fraction of low-risk types, gamma, increased, the zero-profit pooling line would become shallower, and eventually it would cross the blue indifference curve. It's in that case that a pooling equilibrium may exist.